Okay, so let's solve this equation. 25 to the x minus 3 times 5 to the x equals 0. So the first thing I recognize is that I see 25 is the square of 5, which is here. So I can just say that this is 5 squared x minus 3 times 5 to the x equals 0. And now I see that there's 5 to the x common on both of the terms, so I can take 5 to the x out. So now I have 5 to the x minus 3 times 1, so I can just say 3 equals 0. And now this gets cut off because 0 divided by anything is just 0. So now we have 5 to the x equals 3. Now, we can turn this into logarithm form if we use this here. So let's say we have a to the x equals b, which is like what we have here. This turns into, this here, a is the base. So log, and then a becomes the base. So log a, and this goes right here. And this is all equal to the exponent, which is x. So same thing we can apply over here. So we have log 5 times 3 equals x. And if you don't like this type of answer, you can, and if you like change of base, you can also have x equals log 3 divided by log 5. Both of these answers are the exact same. They're just written in different forms. Okay, so number 2 is fairly similar to the one we did before. And same thing here. I see that 9 to the x is a square of 3 to the x. So I can just write this as 8 times 3 squared x minus 3 to the x equals 0. And now I can take out 3 to the x. And then now I have 8 times 3 to the x. And then now we just say minus 1 because all there was 3 to the x and we took it out. So this is equal to 0. And this gets cut off because 0 divided by anything is just 0. So now we're left with 8 times 3 to the x equals 1. And then now we can just divide by 8. And now we have 3 to the x equals 1 over 8. Now we're in that exact same scenario as we had before, except now we have a fraction. And it works no matter if it's a fraction, whole number, whatever it is. So now we have log 3, 1 over 8 equals x. And this is one answer. And again, if you don't like this and you like change of base, you can have x equals log 1 over 8 over log 3. Okay, now, so this question is a little more challenging and takes obviously a lot more steps than the last one. But it's still very simple to solve, and you still use the same methods as you would use before. So first, what I want to do is I want to use change of base for both of these terms. So the base here is 4, so on top the numerator will be log x to the 3 over log 4 plus, now this, we can just keep it, actually, this is a square root, which means it's x to the 1 over 2. So this is log x to the 1 over 2 divided by log 2 equals 8. Now this can actually be 2 log 2, because if you remember, anything that's multiplied to the log goes up to the exponent, and 2 squared is 4. So now how do we make this into this so we have the same denominators? So what we can do is bring this over here. So we can change this 1 over 2 and put it here. And now we can bring this down. So log x to the 3 equals 2 log 2 plus, now we can bring this down here. Since it's going to the denominator, we're going to multiply by Actually, we're not going to multiply. We're just going to reciprocate it. So it's just going to be log x over 2 log 2. And same way, if you were to bring this back up, this would be 1 over 2. If you bring it to the numerator, you reciprocate it. And it doesn't matter. If you put it up or down, you just have to reciprocate it. So if this was 1 over 2, this would be 2 over here. Equals 8. And now we have the same denominators. And this 3 can also just come over here. So now we have 3 log x over 2 log 2 plus log x over 2 log 2. And since we have the same denominator, we can just do, and technically there's a 1 here. Now we have 4 log x over 2 log 2 equals 8. Now, if we cross multiply, we'll get 4 log x equals 8 times 2 is 16 log 2. And we're not going to do 2 to 16 because that would be a really big number. But what we can do is divide 4 on both sides. Now we have log x equals 4 log 2. And now since we have logs on both sides, first we have to do log x equals, and we bring this 4 up here. Now that's a better number. Log 2 to the 4 is 16. Now we can just cancel off the logs. And now we're just left with x equals 16. And that's the final answer. Okay, so the last question looks crazy, but what it's basically saying is 2 to the power 4 over log 4 base 5 plus 3 over log 8 base 7 equals 175. This entire thing is equal to 175, and all we have to do is just prove that. So we're not really solving for anything, we're just proving it. So first, we ignore this equal sign, 175, ignore the 2. All we're going to look at is this exponent right here. So let's take that out. Now we have 4 over log 4 base 5 plus 3 over log 8 base 7. And let's turn this into change of base on the denominator. So we have 4 over log 4 over log 5 plus, same thing here, 3 over log 8 over log 7. And now this is going to be, this goes up here and this goes up here. So 4 log 5 over log 4 plus 3 log 7 over log 8. And now let's bring it up here. So we have 4 log 5 over, now remember, we can make this into 2 squared, and then the exponent can go over here. So we have 2 log 2 plus 3 log 7 over, and this can be 2 to the 3, so the 3 goes over here, so 3 log 2. And now, remember when in the other question, we brought this, there was a 1 over 2 and we brought it down and we reciprocated the number. So if we were to bring it back up, we have to reciprocate it again. So this 2 becomes a 1 over 2 here. So 4 times 1 over 2 becomes 2 log 5 over, now we just have plain log 2. Plus, now if we want to bring this up, we have to reciprocate the 3. So 3 times 1 over 3 is just 1. So now we just have log 7 over plain log 2 again. And now what we can do is this 2 goes up here. So we have log 5 squared, which is just 25. 25, and I'll write it here because now I want to revert it back so it's not in change of base. So this 2 becomes the new base plus log 7. This can stay the same, so log base 2, 7. Alright, now we cleared up some space. Now we have two logs that are adding with the same base. So adding is in logs the same as multiplication. So now we have log 2, and 25 times 7 is 175. And now this is all we can do with it. And remember, this all that's in red is just the exponent. So now we can replace this entire thing with this log right here. So now we have, I can just put it here. 2, and the exponent is this, equals 175. And I know this because 2 is being raised to a logarithm which has the same base. So there's a 2 here, and the base is also 2 here. So this whole thing just gets cuts off and becomes 175. And we just proved it like that. So just remember, if this base and this base are the complete same, if they're both the same, then whatever's here is just going to be the simplified version of this entire exponent.